Hi everyone, myself Dr. M. Karthik, Associate Professor in the Department of IT, Nanda College of Technology. Today we are going to cover the topic reliability of agricultural system in the course IT in agricultural system. Soon we enter to the topic. So first we will see about what is the reliability in agriculture. So in agriculture, reliability refers to the consistency and dependability of agriculture system such as practices and equipments in performing their intended functions under the specific conditions over a period of time. So here we are ensuring the resilience and sustainability in modern agriculture. Here we have to consider the importance of food security, climate resilience and sustainability over the period of time in the agricultural field. So what are the key components of an agriculture system? Here the key components of agriculture systems are land, water, crops, livestock during the production as well as the machineries involved in the agriculture system, then resources such as human as well as the machinery resources are the key components, and also there will be the dependence of the components. For example, if you are considering the human resource as well as the machinery resource, all the things will be interdependence based upon the lands, water, crops, and also the stock management. So here not only considering these things, and also it will be having certain properties of farm systems which activities are involved in the need to be assessed. Here are productivity, profitability, stability, diversity, flexibility, then time dispersion of the farming lands, then sustainability, complementarity, and then environmental compatibility. So these are the certain farm systems and activities which will be assessed to ensure the reliability of the agriculture system. So what are the factors which will be affecting the reliability in agriculture system means? So weather and climatic change, pests and diseases, soil degradation, market fluctuations, policy and human factors. So these are the factors which will affect the reliability. So at the first farm level, the system properties can be quantified and they are desirable, at least a neutral in sense of individual farm, which can rank highly with respect to the productivity, profitability and stability, etc. So after this we have to consider certain things for productivity. So it is a primary measure of the relative suitability of a system or an activity in a particular agroecological environment. So on commercial farms, it is an indicator of relative efficiency of resource use and management performance. So it is an underlying condition for profitability. So but should not necessarily it has to be taken desirable attribute for the things. And also the things which involved other factors other than the productivity and profitability. Stability. The system stability refers to the absence of minimization of year-to-year fluctuations in either production value or output of the things. In such situations, the most direct strategy for stabilization is to simplify the increased production or income to a level which allows an annual surplus to be retained, which will be invested in good years to cover the differences in poor years. So like that we are classified so many things to ensure the reliability. So measuring the stability and instability, we have to identify the things such as price, yield or income stability is the most conveniently measured in terms of efficient and coefficient of variation, which can be denoted by CV. which can express as the standard deviation and denoted by SD, or positive square root of the variance V of a sample observations on a variable x to be a percentage of sample's mean value. So by using this, we can measure the stability and instability of a forming system. So what are the importance of stability, system reliability? A stable yield income, and then long-term sustainability, food supply chain consistency, and risk mitigation. So what will enhance the reliability through technology? How we can improve the reliability? By using the modern technology. It can be done through these kind of things called as precision forming. By using the modern technology, we can do the forming things. So that will be called as precision forming. A smart irrigation system. So irrigation will be the major component in the farmland. So how effectively we can do the irrigation? By using the technologies that will be called a smart irrigation system, such as drip irrigation. Like that, we are using so many technologies for doing the irrigations, as well as drone and remote sensings are used in the farmlands to enhance the reliability. And also we are using the artificial intelligence and data analytics to ensure the crop growth as well as the reliable of the farmlands. So it can be an active diversity throughout the field. So by this we can improve the product diversity, income diversity, then flexibility of the systems. So the property of flexibility of product users provides so many things, such as dimensions to the diversification. It refers to the availability of alternative ways of product disposal, as well as the maximum of 4 ways, such as consume or use, sell, barter, store, or process. So by using this, we can enhance the reliability through technology. Also that we are having traditional methods for supporting the reliability. What are these traditional methods beyond the modern methods, modern technologies, such as crop rotation, agroforestry, mixed cropping, indigenous pest control? So these are the certain factors which will be used beyond the modern technologies. It will be helpful in year by year based upon these things. So case study, what are the cases we have analyzed in the farmland for improving the reliability? For example, we are considered the reliable and unreliable farming setup. We are considering the aspects of our reliable farming as irrigation. We can use the farming setup in modern technologies. We are using drip irrigation with sensors to ensure the water efficiency and timely delivery, and then monitoring the soil health, regular soil testing, crop rotation, and use of organic compost. So what are the technologies equipped with here is automated climatic control, IoT sensors, and AI based crop monitoring. Then seed quality, crop seed quality, to identify and certified the disease resistant hybrid seeds with predictable yields. It can be predictable easily. Also pest management, integrated pest management, as we discussed earlier. What is integrated pest management in the previous video? So it can be used for reliable farming setup. And also we are considering the market linkage and risk management for covering the crop insurance with the weather prediction tools and emergency plans. So for unreliable farming setup, it can depend on irrigation only on the rain feed, and also soil health, and no testing and overuse of fertilizers will lead to a soil degradation. So for technology, not using the modern technology, they'll be using only the traditional methods, no data collection or real-time monitoring. They're using only the manual operations for unreliable farming setup. For seed quality, saved seeds from the previous harvest, no germination or low germination pest management also will not be done. Heavily uncontrolled pesticide use also, it will harm the crops and environment, as well as the intake of humans will lead to severe diseases. So there will be no market linkage while using the unreliable farming setup. So relies on the middlemen, so it will reduce the low prices and faces market uncertainty. And also there will be no insurance coverage for the risk management. So by analyzing the farming setup with reliable and unreliable, we can get benefited by using the reliable farming setup based on the aspects of irrigation, soil health, technology, seed quality, pest management, market linkage, and risk management. As well as we have to consider for the data comparison and outcome analysis of the farming setup. So here the main objective is to compare the different agriculture systems, such as traditional and modern systems, and then rain feed with irrigated, then organic with conventional based methods, on the reliability of the systems. So here the parameters will be used for the data comparisons, such as crop yield, water usage, fertilizer input, pest resistance score, drought tolerance. Then year on year it will be varied. So like that we have certain factors for comparing the data with the modern and traditional methods, and then based upon this we have to identify the outcome analysis. It can be improved a lot of reliability in the agricultural system. So government and policy will play a vital role to ensuring the reliability of the agriculture system. So the government will have announced the subsidies and the crop insurance for managing these things, ensure the reliability, water and land management policies, then agricultural extensions and research for these things. What are the challenges facing to ensure the reliability? What are the things means? Climate unpredictability, input costs and availability, labor shortages, political and economical instability, so that the policies can be changes frequently. So the political and economic instability also faces so many struggles to predict the market analysis. So these are the certain challenges to the reliability. So what are the future strategies will be having to ensure their reliability? Or climate smart agriculture system, sustainable incentivization, integrated farming systems, and digital platforms and education to be given for the farmers as well as the farmland users, such as market trend analyticals, such that we are using these future strategies to improve the reliability of the agriculture system. So finally, I have to conclude the things for to ensure the reliability of the agriculture systems. So we have to invest, educate, and innovate the farmers to ensure the reliability of the systems. Thank you. Identify the data sources and case studies from the different articles, to ensure the reliability of the case study. Thank you.